Hello, today for class math core, okay? So we're gonna continue. The next one is a symmetry. Okay, last lesson you learned about graph of equation. You plot linear equation, and the probability. Sorry, quadratic equation. Okay, so now take a look at the symmetry. Symmetry, can you see that? The graph of equation can have symmetry with respect to one of the coordinated axes or with respect to the origin. Just say that symmetry have three kinds so far, right? We have three kinds, and we're gonna do on the x-axis, y-axis, and the origin. So you see the first one. For example, if you have this graph, okay. So when you plot this one, you want to find the symmetry of a graph. So then along the x-axis, for example, this one want to go to the x-axis. So that means kind of you flip, right? Or reflex. So see this one on the top first. So for example, assume this point is maybe say x equal to 2, right? And y equal to 3. So when you plot the graph for symmetry, so this point have to go down. The height is what, 3, right? Because the value of y. So then you go down here, have to be equal to 3 also, but is become negative. So this one gonna be -3 because this is below x-axis. So below y gonna be the negative side, correct? So x still the same point. Everyone observe x equal to 2. This is x, right? X equal to 2. X did not change. But then y move, right? This one is actually this one is like one part of the transfer. The lesson is transformation, which is at three kind. The transformation at three kind. First one is dilation, second one is translation, and the third one is a reflection, like this one. We want to find the symmetry. So this is a part of reflection. Sometimes we call flip, right? Like this graph, you can flip it up. You still have the same shape of the graph. The graph did not change, did not bigger, not longer, or not wider, still the same shape of graph. So the graph did not change. It's just only flip and to the other side, that's all. But in this case, it's what? Reflection or flip along the x-axis. So this one on the x-axis. So this is the graph. So this one with symmetry, this original. So in this case, you see which one change? Only y, right? Y value change, but x still the same point. So this is a x, this is a y. So x is a 2, this y is a 3, but then this x still 2, correct? But the y is what? -3. Everyone get it? So then this one, maybe I can move up a little bit for this one, right? I want to move up, and then you can see the definition down here. So you can compare. Okay, let's see. Then I will erase this one, right? Back on the top again. So this one, 3, for example, x is here 2, and this one gonna be -3. X is a 2, y is 3. And down here, x still the same, did not change. The one change is the value of y, become negative. And get now. So this one go according x-axis. See this, the condition here, the symmetry, how we the way we're gonna test for the symmetry, right? For question 1 here, along the x-axis, with or say with respect to x-axis. So you see x, y same, but now y become minus, but x still the same, but y become negative. Okay, so now see if go along respect to the y-axis. Okay, if respect to the y-axis, it's gonna be, see this, for example, this one, right? For this side, right? This is the xy. So if want to find the symmetry respect to the y, so this is a y-axis. So this kind you reflect, right? This graph you flip, right, to this side or reflect this side. Just say like this one like a mirror, okay? Think about it, this one, y-axis like a mirror. You put one picture, right? This is a mirror, and then you put any picture on this side. You will see reflect, right? Reflect to the other side. So that's about. So sometimes we call flip or reflection is a path transformation, and that's the way we find symmetry. So if this one x, assume again, assume this one x is maybe what, 2, right? And then y is also, maybe I use the same number, okay? Maybe y is 3, okay? So now when you reflect with respect to y-axis or flip to here, right? You want to find symmetry. So when you move to this side, the graph, this one should be symmetry to the left-hand side, correct? With this is the y-axis or the mirror, okay? So then value of y is still the same, right? Because 3, so y is 3 here. But now 2, x equal to 2 on right hand side, so this side 2 should be negative. So this 2 gonna be negative 2. Get it, right? So then this according y-axis symmetry. So this point x is what, 2, y 3. Okay, so in this condition, meet to the second test here. You see xy, right? Xy is a 2, y is a 3. Okay, and then this one x become negative 2, y still same, nothing changed. Okay, get it? Now this reflect on the y-axis. Okay, so next one, see if go according the origin. Origin, see this one, right? So if you reflect, right, respect to origin, so this shape like this, right? So this one have to go down here, right? Curve and then curve here. So there's symmetry, correct? Symmetry, right? So if assume this one x is a 2 again, and this one assume this is a y, okay? So this one gonna be x2 and y equal to 3. So if they reflect, find the symmetry with respect to origin here, okay? So this one origin here 2, right? But this side gonna be negative 2. And y go down here, correct? When you plot this point, right? X here, y down here. For example, x0, this one x0, right? If x1, negative 1, y have to be go down somewhere here, about negative 1 or something, this point. So this one, when x minus y minus, x minus y minus. So in this case, this one, x gonna be negative 2, correct? Everyone still know how to read coordinate, right? And then this one, y go down here. Should be the same height. Y is a 3, right? So when go down here, the same height 3, y 3 also, but this direction is what? Go down third quadrant is a negative. Okay, so everyone still know how to plot coordinate, right? This one, x is a plus, y is a plus, but this side x is what? Negative. Go down here, y is a negative y. Okay, this is a y plus, this one plus. Okay. Okay, then you see when they find the symmetry with respect to origins, xy, when find the symmetry or reflect it, x gonna be negative and y also negative. See this one. So this one origin. Okay. So if say x2 here, y3 here. So this one gonna be negative 2 and this one negative y. Okay. So the blue color here at the first one I have here is y-axis. See that here. So everyone get it or not? Right? How to see the symmetry? Which one stay? Which one change? And get the symmetry. Symmetry kind of reflection or flip the picture, or can get this the mirror, right? Stay and then put the picture and flip to the other side. So symmetry means the still get the same picture, did not change, and did not get the wider or narrower or something, still have the same shape. Just flip to it to the other side, to the other position. Okay, so now we go next one. Okay, okay. This first example here, the one we have y equal to 2x power 3, right? For the symmetry with respect to both axes. Both axes mean x axis and y axis, and the origin. How we find the solution. The podcast for us already really nice, eh? But then how to podcast? A really easy how to pod. You do the same way we do now. How to pod? Same way like a previous lesson. Find x intercept, y intercept, and a little bit point. That's enough. Okay. So if you get the x intercept, okay, y becomes 0, correct? So you repeat this one, y becomes 0 equal to 2x squared cube, x intercept, okay? Then I want to find intercept. So this case become, so x become x cube equal to 0 over 2, so equal to 0. So no matter what power here, so x, 1x still 0, correct? So we have x equal to 0, 1 when y equal to 0. So this point coordinate point going to be 0, 0. That's why they have 0, 0 here. Okay, this starting point. Now you find, again, this is the intercept, right? Now you find y-intercept. Y-intercept means x becomes 0, right? So you replace x becomes 0 here. So y equal to 2 times 0 power 3. No matter 0, 2 times 0 still 0, correct? Okay, so again, they met at this point. So x-intercept, y-intercept met at the same point, 0, 0 here. So after this, you just try one more point is enough for right-hand side, left-hand side, and the rest you approximate. Otherwise, you find about 0.5 here. Okay, so then from this one, okay, from this one, you replace, if say x equal to 1, so you replace 2 when x equal to 1, right? So you replace this one 1 power 3. So you have 2, 1 power 3 is 1, right? So 2 times 1 is 2. So that means you have now this point what x equal to 1 to y equal to 2. That's why you have here x1, y2. Everyone get? Okay. So then from here you just plot like this. How do you know it's a little bit curved? But actually we know already. You have to keep in mind power 3, x power 3, the graph similar like this. Okay. Otherwise you can find this point maybe 0.5, right? Replace x in 0.5 in here. Okay, just replace x equal to 0.5 in here, and then you get value of y. So it should be somewhere about here. So then your plot graph should be like this. And left hand side do the same way. Replace x with the -1 here. Okay, so then 2 times x equal to -1, everyone. Power 3, right? So 2 times -1 power 3 is what? -1. So come out with the -2. So this one equal to -2. So this point we have x -1, y -2. That's why we have here x -1, y -2, and do the same way. So that's the way the plot graph. We always find x-intercept, y-intercept, and find by left and right side to find another point or 2 points enough, and the rest just approximate. You may not need to use table. Okay, everyone get? Okay, now we go next. How we gonna find the symmetry respect to both sides, right? To both mean x-intercept, x-axis and y-axis. So now you see this original function y equal to 2x squared. So right now you want to test is x-axis. So from previous, right? So x, you see this one, right? This graph, you can see this side first. If you want to find symmetry according this one along the x-axis, that means this graph have to flip down like this, right? if x-axis, right? So this one from here to here, from here to here, right? So it's a y is equal to 2 is the height. So you have to go down here also. The height, the same height should be here. Okay. So this one about 1 here, about this height, go down 1 here. So then you can plot this graph down. Should be some curve like this. Okay. That's a symmetry along with the x-axis. Okay. So if you symmetry with the x-axis with respect to the x-axis, right? So you can see this point we're gonna be x is 1, correct? Nothing changed, but y become -2, right? A1, this one symmetry to this one or reflection or flip down here. So in this case, you replace y equal to replace the just say side, right? You can see this one, you replace y. So y gonna be negative. So you just write here y become -2. Then now this question they just show you only the side. Okay, just show the side only. So y become negative here. But the x the same, this one nothing change. So when in this case you see these two here not equal, right? That's not equal because this one have negative. So that's why they said the result is not an equivalent equation. But that's the way if they find symmetry along the x with respect to the x-axis. Okay, everyone get? So now again, if I do this one for the next one for the y-axis. For the y-axis, you see what the y-axis mean here, right? So you have to reflect like this to this side, correct? So this one to here is about 1, right? It's an x, right? This one's an x. So just say this how long this side go the same long. Okay, for example, this one x is a 1, correct? So this one should be 1 here also. Okay, and then to this side. So then you plot to this side like this. And this is so this one gonna be what? Right now this point is what? X is a -1, y is 2. Which one change? X value change, right? But y same. See, this 2 is a y, this 2 is a y. X is a 1, but this side become -1. So because this one reflect or symmetry with respect to the y or along the y-axis, okay? This and flip. This one like a mirror now, right? The x-axis, the question A here, x like a mirror, correct? And this is a reflect. And get now, so this is the y-axis. So then when you see this one, with what number change? Y, x, right? X become negative. So you see this one, they replace x with a negative sign. Okay, because they did not replace here, x can be anything, right? Up here, right? To down, up here, and y go up. So, but whatever, they just replace x is a negative side, right? Because x change. So this one, x become negative here. So negative, any number, real number here, x is a real numbers, right? When the power odd number come out, have to be negative side, correct? So then this one come out here, y equal to 2x, this one. And this one become minus x cubed. So this one does not equal either. So the result is not an equivalent equation. Okay. But then you see the last one, origin. Okay, origin. So from the period, remember the table, we do the testing for symmetry. We have three kinds, right? X-axis, y-axis, and origin. So now origins mean what? If the reflex or symmetry along the with respect to the origin, xy change, correct? Xy change, correct? So this one, if you see this one, right now this one, right? Then the reflex or symmetry, this one, and get. So then you see this one, this side is what? XY is a plus, right? But when you come down here with the same number, right? But let's change direction now. X a negative, come down Y negative. So this one have be, this side X1. So this one become negative 1. And this one 2 become negative 2 because X is a negative here. This side is a X minus. And Y come down here. Y is a value is a negative. So that's why this one replace Y with a negative and X with a negative. Right? So because power odd number here come out should be negative sign. So negative, and then negative you can time or divide with a negative one, both sides come out become positive. So then from this one, the original question here and this one, see that they are same. So that's why they say this equivalent equivalent equation, they're equal. Everyone get how to say how to get the symmetry. Actually, symmetry, think about reflection. That's it. Reflection, right? Think about flip the picture. Get X to along X. So X like a mirror. If you reflect along with or with respect to Y, the Y is a mirror. So if this one origin, so this one actually origins like a X equal to Y. Is have one line. Linear, exactly 45 degrees. Okay. Okay, so this about example for symmetry. Now go next one, example. Down here. This one, right? Use symmetry to sketch this graph. Okay, now we can put this graph together. How to put graph? If this one, can I erase it? I need more space. I erase. Now I'm gonna put graph for this one. So actually this one, right? This question plot graph, they give us x minus y square equal to 1, right? So I can move back, become x minus 1 equal to y square, correct? Move plus 1 become minus this side become y. So I can write it this way, correct? Y equal to x minus 1, right? So then I plot graph, okay? So y power 2 here. So then this one equal to what? You can take the square root, correct? Become x minus 1. And then because it's a power even, don't forget we must have plus and minus, correct? This one really important. You must have plus and minus because the index here is a positive. I mean it's an even number. Okay, so in this case, you're gonna have what? Gonna have two equations, right? You're gonna have two equations. You're gonna have two equations. That means, come back here. So we're gonna have this one, y equal to square root x minus 1, right? And another one, y equal to minus square root x minus 1, right? So now remember, we learned this one a little bit from last year. If we want to find domain of x here, we want to find domain of x here. We get inside under root, right? Under root can be 0, correct? So we have to write it down, say, we become x minus 1 have to be what? Greater than or equal to 0, correct? If under root become negative with any number, normally we always say it's undivided, right? Or no solution. So under root have to be greater than equal to 0. Have equal to 0 also, correct? Greater than mean x have to be positive, have to be plus sign. And if square root 0 is a 0, correct? So see, okay, so have to be equal. Okay, so then you plot graph, this one how to plot. So x greater than equal to 0, right? So after this one, we can have what? If you solve the question, x gonna be what? 1, right? So x have to be greater than equal to 1, right? So then you start x, that means x gonna be, if you put a number line, everyone recall this one, or maybe you haven't learned this one. So if x equal to 1, right? So this one, if you put number line, yeah, you learn real number, you remember, because right now x is a real number. So x equal to 1, so real number, that means like this, right? So when you put the graph on the number line, you learn already last year about real number. So x can be 1, can be 1.0, can be 2, can be 3, can be until plus infinity, right? So that means when you plot graph, when we plot graph here, right? When we plot graph here, so this is 0. So x greater than or equal to 1, right? So then x have to start from 1, right? So you replace x equal to 1 in here, either one, equal to 1 here, right? So if you replace x equal to 1, so x equal to 1, y becomes 0, correct? Square root, take square root 0, 0. So this one gonna be, if x1, y 0, so at this point, correct? Get or not? And then if x equal to 2, right? For example, we use an easy number. We don't need to use decimal. If x equal to 2, you replace here. X equal to 2 minus 1. This is a y, okay? And now it say x equal to 2. So y become what? Square root 1, right? Square root 1 is a 1. So now we have now x2, y1. If x2, y1, so here x2, y1 go up a little bit, assume 1 here. So and this is point. So after this is enough. It's enough. You don't need to go on. If you want to go on, maybe try one more. If x equal to 3, right? So y become what? 3 minus 1. So equal to square root 2. So square root 2 approximate what? 1.414. So if x equal to 3, for example here, 3, 1 point, this one, 1 here, 2 here. So 1 point something approximate here is okay. I don't need exactly, okay? So this one should be a little bit curved, okay? This one should be curved like this and go up to x infinity. So this is a graph you're gonna have for this one, for this question, okay? But why negative doesn't work? I mean this one, if x less than, x have to be greater than or equal to 1. So x, when x go to left hand side here, like a x equal to negative 1, I mean, if x go to, say, this one 0, right? If you replace x equal to 0, now come here. If x equal to 0, right? So you replace 0 minus 1. So you have square root negative 1. So undefined, right? So we don't have from this side like a less than 1, no more, because gonna be all negative. Because if you replace x equal to negative 1 here, x equal to negative 1 here, so this one gonna be what? If x equal to negative 1, right? So minus 1 come out become square root negative 2, then again cannot undefined, right? So this from the left hand side, so less than 1, no graph. So no solution for the graph. So only this one, okay? So in this case, they want you to set the graph. This is the graph, okay? Otherwise, see this, they hand out, they show you the table, but I think table is take too long time to do. Okay, now I move up a little bit here. See this question, how they work for you, right? You see down here, right? Down here. So maybe I erase here. So this the question we just plot graph. This one. Everyone see this? This the question. Oh no, up here, sorry, this one. This question. This one, okay, this one. So we plot graph here, this one, right? This curve, and this one is the curve. The one we have, the same, right? Same, right? But then the one you find symmetry here. So symmetry, then let me see. See, when for symmetry, right, you just, for example, this height is 1, so go down 1. For example, this height is what? 1 point something, you go down 1 point something. So this one gonna be, this one 1, right? So this one gonna be -1. And this one gonna be the square root 2, remember, 1 point something. So your graph should be symmetry like this, correct? So that's why we have this one. This one down here is a symmetry graph. Okay. So you can see this one is happen symmetry on what? On x-axis, correct? Because then you can have x is the same point, but y change, right? Y here's a y plus, and x the same. This is x the same, but y become minus. Everyone get it? Okay. So just repeat again, right? Now come to this next example number 7. Example 7. See that? See, they want you plot this graph absolute y equal to absolute x minus 1. Now they use table. Now they use table here, right? They use table by make like you learn from grade 9, right? Some with some teacher, not sure. So you use table, right? Like a 0, 1, 2 to the right hand side, left hand side, and then you replace. For example, x equal to -2, you replace here -2. Okay, now we work together, -2, -1, absolute. So become absolute -3, right? So absolute is plus, right? So come out become 3. That's why they have 3 here. So the coordinate point at this one gonna be -2 and 3, and so on. You keep doing. So they use table. This one they use table how to do, right? And then you plot graph according this one x and y. So you plot like this one, when you replace -1 here, right? You replace here -1 become -2. So absolute -2 come out become +2. So then you have coordinate -1 and 2. X become -1 and y equal to 2. Then you plot graph, right? -1 gonna be here, and y is a 2 go up here. So this point, okay. And this one x0, y1, x0, y1 gonna be this point. And then you plot according this table. So this is the way they do by using replace in the table. Use table, right? But for me, I will tell you how. By plot graph fast, we don't need this table. It's kind of tedious, take a lot of time, right? So do this way. Come here. I will tell you how to plot graph fast. Okay. Now this is a y. This is a x. Let me erase this one. I erase the old one, okay? So make clear area here. This is x, right? This is a -x, this side plus x, okay? So then how we plot graph for this one? You can do by, where I need some more space. Can I write it down somewhere here? Eh? I write down here, I think. I erase this one. So this one y equal to absolute x minus 1, right? So I write down this one y equal to x minus 1 first. Okay. Underline, so you won't be confused. Right now I'm doing this one, x minus 1, x minus 1, okay? Like y equal to x minus 1. I won't do the absolute yet. I take inside the absolute. So y equal to x minus 1. After this one, again, find x intercept, y intercept. That's it, okay? And find a little bit left and right hand side, one more point is enough. And the rest just approximate. So I need the main idea, that's all. So if you find x intercept, again, y equal to 0, right? So y equal to 0, you replace y equal to 0, x negative 1. So from here, x equal to 1, correct? So now this point you have now become x equal to 1, y 0. Okay? So now you plot x1, y 0. We plot it now, x 0, x1. So x1, for example, x1 here. Y gonna be 0, so this point, correct? Now we go to get the this one's the x-intercept. Now I want to get y-intercept. Y-intercept means x equal to 0, right? Equal to 0. So then you replace x equal to 0 here. So 0 minus 1. So they got negative 1. So this point you got x0, y negative 1. Everyone get? So now you put x0, y negative 1. x0, y negative 1 go down here, negative 1. Okay, this is a negative 1 here. And this one's a 1. So when you have x-intercept, y-intercept, that's enough. So you draw like this. Okay, draw one linear. Or if you want, you can find one more like if x 2, right? So maybe, okay, but actually I don't need it. So if say, if in this case, say x equal, let me see, use another color. If x equal to 2, right? So you replace here. So become what? Y equal to 2 minus 1. So equal to 1, right? So this one you got is what? X2, Y1. So now you plot this one. X2, Y1. X2 here. Y1 go up a little bit here. So assume 1 is here. So this point. Okay. So now we have it now. Should be enough. Or you can put this side one more point up to you. Negative 2. So replace this one negative 2. Y become negative 3. So y negative 3. Negative 1, negative 2, negative 3. So it's about here, negative 3. Okay. So I think this is enough, this one. So then you draw the line. The main thing is here, x intercept, y intercept. And bring down. Should be linear, okay, straight line. And actually this one should be end with the arrow because the value of x and y go to infinite value, okay, because they did not fix the domain, so you can go up, go to the infinite. So this one, everyone remember this graph is what? If only this one, okay. So from this one, if only this graph first is an increasing function or decreasing function. Increase, right? You always see from the left. Last lesson we learned already. You see from the left hand going up, 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 up here, right? Okay, so this is the increasing function. Okay, now after I got this linear, because y equal to x minus 1 is a linear, correct? Because x power 1, right? So it's a linear or straight line. So I got straight line and go increasing from left to the right hand side because x pass here. Remember from that lesson? So graph should be like this. Okay. Now, after this one, after this one, right? I have y equal to x minus 1, correct? For me, this one. Then if I add the absolute, the next one, if I add the absolute, inside the absolute have to be what? Always plus, right? So when I have this one, when I write the absolute, all the graph below x, any graph below x have to flip or reflect it up, reflection. So from this point, this one down here is a negative because below, right? Below x, y is a or the y is a negative side. So from this one, you flip up, reflect, right? So then this one from this is a negative 1. When you flip this one, gonna be 1 here. Okay, so from this the same height, go the same height. And this one about negative 3, right? So you have to go up negative 3 here. This one 2, this one 3, right? So this one about 3, correct? The one we just find. Just say about this height is enough. You don't need to find actually. This one same height, right? So same height, so somewhere here. So this one defect here, right? So you draw the line. Then from this one, you draw up the line. Oh, sorry. Go up like this. Okay. Then this one. See this one, you see from the graph from the handout here. This line, right? Mean the green line, what I have here. Okay. So this is the same line. And this one's the orange color here. Same, this orange color. Okay. So now, when you flip it up, the orange color here below x-axis no more. Okay, you can write it down with a broken how to say broken line, or you can erase it after then. So there's no more because you flip up already above the x-axis. Because y have to flip up this one because the whole graph have to be positive. They have to be above the x-axis. So final graph gonna be this green and the yellow, means orange here. Same with the example. Everyone get? So now this, I think this one faster than you use table, right? You can practice one. I will give you more like this one, and you can practice. I think you will get it really soon when you practice 1 or 2 questions in this style. In your level about this one only, you won't go deeper than that. Okay. You learn like a more like a reflection only, did not learn another transformation. They have dilation, this one harder, and the translation, this reflection easier. Okay, so now I think should be that's all, and then see you next one. Okay, bye bye, see you next lesson. Bye.